Welcome back. In this class, we are going to discuss about an application of other forms of Cmos logic. Now, the first other form of Cmos logic application is the application oriented circuit, that is a C-square MOS, where C-square is nothing but clocked complementary metal oxide semiconductor. This is the general structure of C-square MOS. If you observe that, let us consider if this part is not there here, if this part is not there, okay, now you can observe that it is similar to what? CMOS. It is similar to a static CMOS. But here a very important point you have to observe. In your static CMOS, we are adding two clocks. One is PMOS clock and another one is an NMOS clock for synchronization. Okay, that means in a single circuit you are having a static CMOS concept and a synchronization concept. Is it understood? Now you can observe this. This is one type of application of other forms of CMOS logic. You know very well that what is a dynamic CMOS. You can observe that dynamic CMOS. Okay, in dynamic CMOS you are having a clock like this and you are having a network in this fashion. Is it clear? And you are having a clock, only one clock you are having, then you are having a network. Based on the network you can take the output from here or else here. Is it understood? Now you can observe that here to maintain the synchronization they are going to use two clocks here. Okay, now you can observe very clearly when pi is equals to 0, what is happening? Observe very carefully. These two transistors will turn on. Why? Because when pi is equals to 0, these two transistors will turn off. Why? Because when pi is equals to 0, this is an NMOS, it will be turns off. This is pi complement. When pi is equals to 0, then pi complement becomes 1, then it is a PMOS, it will turns off. Therefore, you do not have any path from either PFET logic or from NFET logic. Is it clear? Now don't forget that here, what is this PFET? We have to tell PMOS network. Absolutely, it is a PMOS network itself. It is NMOS network itself. Don't confuse with this FET. Is it okay? Now you can observe that when pi is equals to 0, since this network doesn't have any connection to the output side and this network also doesn't have any connection to the output side. Is it understood? Now you can observe very clearly what happened when pi is equals to 1. When pi is equals to 1, since it is an NMOS, it will turns on, and since it is pi complement which is equals to 0, it is an PMOS, it also turns on. Therefore, there is a path to the P network and N network to the output side. Then it is going to be depend on whom? The inputs. There you may have the static logic. I hope that are clear, all of you. Now you can observe some of the examples based on this. Now will you please tell me what is this one? Anybody from the class? Yeah, absolutely. What is this one? This is an inverter. Is it clear? Now you can observe that very carefully. Why I am calling this one as inverter? We know that inverter consists of only one input. Okay, then you are having only one input here, V in, and output is there. And don't forget, since it is an inverter, only one transistor of PMOS and one transistor of NMOS should be present. Don't forget the middle portion, that means the synchronization portion should be common. If you take pi here, then definitely it should be pi complement. Then here you should have a PMOS network, and here you should have a NMOS network. It should be connected to VDD and it should be connected to VSS, and common inputs are given for both. Is it clear? Always we know that the output is taken between P section and N section. Here the output is going to be taken. Is it clear, all of you? Now you can see some other examples based on this. You can observe what is this figure? Can you please explain what is this figure represents? Yeah, absolutely. This figure represents the circuit operation depending upon the clock. You can observe that here I can clearly tell that when pi is equals to 1, okay, there is a path from this network and this network, it depends on the input. Now you can observe when pi is equals to 0 here, when pi is equals to 0 here, there is no path. This dotted line represents the path is removed. Is it okay? That is an important point you have to talk about. Now some of the examples of clocked CMOS, you can observe that. Yeah, observe. This is, what is this one? Can anybody try to tell? Okay, it is a buffer. Why? Because back to back inverters are connected. Then you may call this one as what? Buffer. Is it understood? We know very well when an inverter is connected to other inverter, then this entire configuration we can call it as what? Buffer. Therefore, we know very well this is an inverter and the output is connected to the other inverter. Therefore, you can call this one as buffer. Is it okay? Now, some other examples you can tell. Can anybody try to tell what is this one? Absolutely. These are the examples of what? NAND gate and NOR gate. You can observe if you want. We know very well in the previous concepts. Okay. I said already some keyword to you. What is that keyword? Absolutely, PAP. Okay, that means PMOS should be parallel in either AND or NAND configuration. Now you can observe that here. Okay, two PMOS are there. Two PMOS are there. You can observe very clearly from this. Two inputs are there. Okay, PMOS are connected in parallel. Then clearly I can tell it is, there is no inverter here. Then I can tell it is two input NAND gate without looking the NMOS. Is it clear? Here you can observe that two inputs are there. Okay, two PMOSs are there and they are connected in series. Therefore, I can tell this is what? NOR gate. Is it clear? Now you can look the entire circuitry in this fashion. Is it understood? This is regarding about clocked CMOS. Depending upon this, you can able to design any Boolean function using clocked CMOS. Okay, the main advantage of this clocked CMOS is you can able to maintain the static CMOS along with the synchronization. Is it understood? Thank you very much. If you are having any queries, please comment. Thank you very much. Have a nice day.